Earlier in the semester, we looked at solving linear equations. And when you're solving a linear equation, you have one unknown, where that unknown, that variable, is raised to the first power. So 3x plus 6 equal to 5x minus 9 would be an example of a linear equation. And we can solve this linear equation following the steps that we use for all linear equations. I'm going to subtract the 3x from both sides, and then add over the 9, and then finally divide, and you will wind up with one solution. That's how we solve our linear equations. But what happens if it's not one variable, but two variables, and I have something that looks like a 3x plus 6 equal to y? Well, now I have an infinite number of solutions. I can plug in all sorts of different things to make this equation true. For example, I can let x equal 1, and then that means that my y would be equal to 9. I can let x equal 3, and then I would have the y equal to 15. And any number that I can think of that I can pick for an x, I can plug that in, and I can generate a y value. So when you have a one-sided or two-sided, something where you're solving an equation, that's one solution. But if you have two variables, then we're going to have an infinite number of solutions, right? And that's my symbol for infinite. So to see what that looks like, we'll generate a graph. And usually when we talk about the equation of a line, we are talking about y equals mx plus b, where m is my slope, and slope is the tilt of the line, how fast it's going up or down, and b is the y-intercept, where it's going through my y-axis, which is my vertical axis. My horizontal is my x-axis. And so if I wanted to graph all of the solutions for the equation we saw on the other page, the 3x plus 6 equal to y, I could begin at b on the y-axis, and here's my b, which would be at the 6, and then move according to the slope. Now the slope we usually think of as rise over run, and I know I wrote that wrong. Rise, you're going to go up or down by whatever number you see in the numerator. Up if it's positive, down if it's negative, and then we almost always run to the right. We could run left if we move the negative, but we normally have it set up so that the negative is up in the numerator and that we'll run to the right. If it's not a fraction, you can make it a fraction by putting it over 1. So here, my slope is 3 over 1. Go up 3 from the point that you began at, 1, 2, 3, and then run right 1 and make another point, and that's your line. Now you can generate lines on your calculator, although it may not really be worth your time too often, by going into the y equals and then just typing in what you see. Now notice that you have this y equals, so it has to be set up in this form where the y is isolated. Sometimes they don't give it to you where it's already in a y equals form, and you'll have to rewrite it. I put y equals 3x plus 6, and when I hit graph, my line will come up. And so you can generate all kinds of lines in there. So if it starts at an unusual B, or you have a very big M, you can go ahead and put that in there and generate the graph any way that you want. Now, since I was given the line, it was very easy to graph. Sometimes they give you the line and they say, well, what's the equation? And so that we would have to pull the information off the graph. Example number 1 provides us with this x-intercept right here on the y-axis. So I know if I'm talking about y equals mx plus b, the y's and x's stay, and what I need to do is plug in m and I need to plug in b. Well, b is at the positive 6. So I put plus 6. To get to the next point, that's how I'm going to find my slope. This is a negative slope. So if your line is going down from left to right, then you're going to have a negative slope. Our other slope was positive because as I went from left to right, it went up. So here I'm going to have to go down 1, 2, 3, and then run 1, 2, 3, 4 to get to the next point. And so my slope would be a -3/4. And the equation of the line would be a -3/4 x plus 6. Sometimes they don't give you the y-intercept, and so you have to just use 2 points that you have on the line. So I'm heading up from left to right. I would have to go up 1 and run 2 to get to the next point. So I know that my slope is a 1/2. And you can extend this line if you wanted to and see where you would cross through that x-axis. Or, since we know m now and we have an xy pair, I'll use this xy pair right here at -6, 5. I can plug my numbers into the y equals mx plus b, because I know y is a 5, when m is a 1/2, and x is a -6. And now I can find b by just solving this one-step or one-sided equation. And I would get b is equal to 8. And so that this equation of this line would be y equals a 1/2 x plus 8. So it's not too bad. But normally they don't give you the graphs at all. Graphs take up a lot of space. More likely what you'll see is find the equation of the line. They'll give you a point on the line and the slope, or maybe they'll give you 2 points on the line. So if they give you a point on the line and the slope, you have 2 options. You can say y equals mx plus b and do what we did on the previous slide. Plug in your y value, your x value, and your m value, and you can solve for b. The trick is that when you solve for b, you are not done. B is not the equation of the line. That is your y-intercept. So you then have to take b and plug it back in to write the equation. And so that the equation of this line would be y equals 1/3 x plus 3. Another option is something called point slope. This is slope intercept form. We're not creative in math. Here's your slope, here's your intercept, so we call it slope intercept form. The other one is point slope, because you need a point and you need a slope. And what you would do here is you would plug in your values for m, x1, and y1, and then when you are done cleaning up the expression, you'll be left with the line. So I could say y minus the y that I had in the point, which is 5, 1/3 times x minus the 6. Distribute the 1/3. So I have 1/3 x minus 2. And now add over the 5. And when you're done, you're done. You don't need to go back and plug anything in. When you're done putting it in y equals form, you'll have the equation of the line. So that is your other option. Which method you use does not matter to me, whether you want to use slope intercept or slope point. Another thing they can do is just give you 2 points on the line. Now you could graph the 2 points and count it out, but depending on what the values are, that might take a long time and a lot of space. So what we could do is use the slope formula. The slope formula is the change in your y values over the change in your x values. And sometimes you'll see it with little triangles. Delta y over delta x. And delta just means what's the difference between those two. It doesn't matter who's x1, y1, or who's x1, x2, y2. I usually make my first point x1, y1, and my second point x2, y2. But it doesn't matter. If I change those, I would get the same answer. The only rule is that the subscripts have to match. So if I make 3 x1, -2 has to be y sub 1. And if 2 is x sub 2, then negative 6 has to be y sub 2. Now I can find the slope of this by just plugging in the values. Negative 6 minus a negative 2 over 2 minus a 3. When you're subtracting integers, you're really adding the opposite. So it's a keep, change, change. And I have a negative 4. Keep, change, change. And I have a negative 1. And negative 4 over a negative 1 is just a positive 4. Now I would take my slope, and whichever is my favorite point, I'm going to pick point 1, and use one of the methods we used on the other slide, whether it's the slope-intercept or the point-slope formula. I'm going to use the slope-intercept. I'm going to pick my y value from the first point, take my slope, and then since I use my y value for my first point, I'll have to use my x value for my first point. And I have my b value. And now I have m and I have b, so that I know the equation of the line. 4x minus 14. I could graph that by hand, or I can go to my calculator and say 4x minus 14. But now when I graph it, you're not going to see the intercept because I'm on the standard page from negative 10 to positive 10. So I'd either have to increase my window manually by saying, oh, I need to see a lower y min, so I need that to maybe be a 20 so that I could see that. Or you can use the zoom, and you could try zoom out, or if you scroll down, you can use zoom fit. Either one is fine. And then you can see your line. Sometimes we want to talk about what would happen if I have more than one line on a particular plane. And there's only 3 things that could happen if you put 2 lines on the same plane. They could intersect, and sometimes they intersect in a very special way where they're perpendicular. They could totally miss each other all the time where they're parallel. Or the third thing, it could be that they're actually the same exact line and they land right on top of each other. We don't need to graph the equations to see what's going to happen. If I have them in y equals mx plus b form, if they're in slope-intercept form, then all I really need to do is look at the slopes. If 2 lines have the same slope, they're parallel, and this is the symbol for parallel, these 2 bars. So y equals a 2x plus 3 and y equals a 2x minus 7 are parallel. If I graph both of those on the same grid, 2x plus 3 and 2x minus 7, they'll never oh, I hit 34. Well, those are parallel as well, but we'll never see the 34, so let's get rid of that. There goes the plus 3. There's the one, the minus 7, and they'll never intersect because the slopes are the same. So think about driving down a 2-lane highway and both of you guys are going at the same exact rate, at that same speed. One's never going to cross over the other. More than likely, the 2 lines would intersect if you put 2 lines on the same plane, but they could intersect in a very special way where I have perpendicular lines, and this is a symbol for perpendicular, this kind of upside down T. Perpendicular lines create a 90-degree angle. So we are very interested in perpendicular lines. 2 lines are perpendicular if their slopes are negative reciprocals. And so if you flip and switch, flip the fraction, switch the sign, then you get negative reciprocals. So y equals a 2x plus 3. If I flip the 2 to a 1/2 and then negate it, I get the negative reciprocal, and a negative 1/2 x minus 7 would be generate a line that is going to be perpendicular to the 2x plus 3. Notice we don't really care about the b values. What we're only caring about is the slope. How fast is the car going? We don't care what kind of car you're driving. So they may give you a question that says, find the line parallel to 3x plus 4y equal to 12 going through the point 2, 9. Well, there's an infinite number of lines that are going to be parallel to the 3x plus 4y, but only one is going to be going through the point 2, 9. That's a very famous theorem by Euclid. The problem is I can't just pull out the slope from this because it's not in point slope or slope intercept form. So I need to rewrite this so that it says y equals, and then all the stuff over to the right. So the first thing I'm going to do is bring the 3 over to the other side. And so I now have 4y minus 3x plus 12, and then divide everybody by the 4. And so that I get y equal to a negative 3/4 x plus 3. And we really don't care about the 3. All we really care about is that the slope is a negative 3/4. So now I have my parallel slope, the negative 3/4, and I have the point on the line. And I use my favorite method. I'll use y equals mx plus b again, to find the equation of the line that's parallel to the given line, but going through the point 2, 9. Y is a 9, m's a negative 3/4. I have a 2 for my x, and I need to find b. 9 is equal to a negative 6/4 plus b. Add the 6/4 to both sides. And probably one of the best things that this calculator does for you is that it will add fractions for you and reduce it. So you can say, oh, 10.5, math, enter, enter, and it will change it to a reduced fraction. And my b value is 21/4. So the equation of the line that's parallel to 3x plus 4y going to 12, that goes through that particular point, is y equals a negative 3/4 y. Negative 3/4 x equal to plus 21/2. Now this form is different than this form, right? This has x's and y's together. This is the y is isolated. We normally prefer to have the y isolated, but every once in a while they like it in this form, which is called standard form. If you want to go back to standard form, all I would need to do is bring the 3/4 back over to the other side, and then multiply everybody by the common denominator, which is going to be a 4. So that 4 will divide out with that 4, and I'm left with 3x plus 4y. And now this will be 84/2, or 42. And notice that this is the same. The only part that changed over here is that b value. If I want to look at perpendicular, and this is our last example, then after I isolate this, it's a little bit faster, right? I can bring the 3 this way and the y over that way. Once I find what this slope is a 2, I can find the perpendicular slope by flipping the fraction and changing the sign. This time I'll use point slope. Y minus y1 equals m times the quantity x minus x1. Y minus the negative 5 equal to a negative 1/2 times x plus 2. Scroll down. Minus a negative 5 is like plus a 5. I'll distribute the negative 1/2 so that I get a negative 1, and then subtract the 5 for a negative 6. And again, this is in slope-intercept form. If you want to go back to standard, which is ax plus by equal to c, just bring your x back over to the same side with the y, and multiply everybody by the common denominator. And you'll have these two lines, which look like they're different, but they are the same exact line. So if you were to plug a 1 into this, right, a 1 in for x and a 2 in for y, well, that doesn't work. If you plug in a 1 here and find out what you would get out for a y over there, you would get the same solution over on this side. So there's two different forms, but they generate the same line. And that's how you graph lines, find equation of lines, and find equations of parallel and perpendicular lines.